Hi, welcome to Aircraft Simulation Tutorials, Tutorial 3, where we're going to add aerodynamics to an aircraft and verify the aerodynamic properties in a wind tunnel. So what we're going to do is take our blocky aircraft model and we're going to add and configure AeroObjects for the wings, tail and fuselage. And we're going to add some visualization components to that in terms of lift and drag arrows. And then we're going to put our model in a virtual wind tunnel and verify that the aerodynamic behaviour is what we would expect. Okay, so here we are in the aircraft design demo scene from before. We've got our blocky plane that we made in the last tutorial where we added in our inertial properties with a rigid body. And what we're going to do now is add some aerodynamic properties to this aircraft. So if we go to our blocky plane in the hierarchy, let's create a directory or a transform called Aerodynamics, and this will hold all our different aerodynamic bits and pieces. And so let's start off with the wing. Let's create an empty object called wing. And over here in the inspector, what we're going to do is add component, and if you start typing aero, it'll find AeroObject, and that's what we need. And in terms of the models we're going to use, we're going to have this object's going to have drag and it's going to have lift. We can ignore these ones for now, but the rigid body is where the forces are applied. And if you remember from the previous tutorial, the rigid body is where if you apply force or gravity, that's what manages that and sends those forces to the physics engine. So we need to tell that rigid body that there's some aerodynamic forces being applied, and we do that by connecting that rigid body here. So what it says is this aerodynamic object is going to apply its forces to the rigid body on blocky plane. Okay, we can't see anything yet, but if we click on the Gizmo icon, if that wasn't already on, what you see there is a kind of blue rough sort of sphere thing appearing, and this is a kind of visual representation of the geometry of the aerodynamic body. So at the moment, effectively, what we've modelled is a sphere. If we want to do a wing, what we need to do is shape it into some sort of wing. And what we're going to do is use the keyboard shortcuts on here that will speed up no end the process of shaping things. So if you want to move something, that's W. If you want to rescale something, that's R. So I'm going to hit R, and you can see these arrows turn into blocks. So I can drag them like that, and I'm going to pull them out, stretch it in, and let's look from the top so I have a better view of what's going on. And if I click in the square in the middle, it turns into isometric view. So I was pretty good on my span, a little bit wide on there. Click W, I can move it in. Back on R, I can shrink it. That'll do for that, and let's look at it from the side, and we'll make it a bit thinner. So it's not crucial really at this for this activity, this exercise, to get things perfect. It's just a rough shape so we can see what's going on. Okay, so that's our wing. One thing we will be doing is testing this in our virtual wind tunnel, and what we need to do is a way of communicating the fact that if we're inside a zone with wind in it, that this surface is going to experience that wind. And what we're going to do for that is a special type of collider. We're going to use a sphere collider as a trigger, and that's going to allow us to interact with wind objects. The details how it works, not important. I'll just show you how to connect it up. So if you start typing sphere in there, you get sphere collider, and we're going to use it as a trigger. So ordinary physical colliders are there. If you hit something, you bounce off. When it's a trigger, this means that when you go inside another zone with wind in, it'll pick up those wind values. And you can just about see the big circle around there. I'm going to localize it a bit more just so it's focused on the wing, and it visually doesn't get in the way. So you can see that green thing there, that's our kind of sensor for that aerodynamic object, so we can sense what's going on in the environment. Okay, what's next? One of the things about aerodynamics is it's really hard to see wind, but you can actually visualize the forces. So we've got some tools here where you can add arrows to show the forces. So we can do add component, and if you start typing lift, you should get lift arrow coming up. and we set the diameter. 20 centimeters is a big. 5 is about right for this size of plane. Leave all those the same. It's going to be green, and so that lift arrow is going to pick up the value of lift from this model here and then tell us the magnitude of the lift. Okay, good, that's our wing. We now need to do the same for the tail. Because we're lazy smart as usual, we're just going to duplicate that and call that tail plane. And if I go to W for moving it and drag it to there, I'm going to look from above, hit the square to go into ISO mode if you need to, and then I'm going to rescale it to the size of the tail plane. Sideways on. There we go. Everything else is the same. It's got its trigger collider for the sphere on it, and it's sending its forces back to the rigid body on the plane. Okay, that's good. Let's make a fin. And the fin is orientated 90 degrees, so we want to rotate 90 degrees around the blue axis, which is Z. So let's put in 90 there. It goes round. Let's look at it from the side. Rescale. Shift it up. Okay, jobs are good, and we've got ourselves a fin. What else? Let's have a fuselage. Fuselage is slightly different. It's still probably quicker just duplicating existing object. Fuselage. And in this case, what we have is, if we rescale it, it's going to be shorter that way, and it's going to be longer that way. So let's look at it sideways on again. W to move, put it in the middle of the fuselage. R for rescale, a bit bigger that way, a bit shorter this way. This is not an exact science, but it's just about getting roughly the right answer for this. A bit skinny that way, so let's make it fatter. And so that body there represents, so in terms of aerodynamics, it's just going to have drag on it, not lift, and it will, depending on which way the wind's blowing, that will give approximately the right sort of drag for that sort of shape. Okay, so lift hasn't got lift on it, so let's get rid of that one, but we do want drag on it, so you can put a drag arrow on it. Drag arrow. Diameter, same as the other one, let's call it 5 centimeters. And because the drag is much less than the lift, I'm going to make it much more sensitive, so I'm going to put a factor of 40 in there. So it just means we can see it. When we put the wind on, we'll be able to see it. Okay, collider's connected, trigger has drag, excellent, I think we're all there. So let's just have a look at the whole thing in terms of all the bodies, just making sure it makes sense. So I've just shift selected all of those so we can see them all at the same time. Go back to W, so we've got our familiar arrows for directions. But there, that's from an aerodynamics point of view, or low order aerodynamics, and that's what a plane looks like. We've got a fuselage body, a wing body, tail body, and a fin. And that is enough to model the basic aerodynamics of a plane. And in fact, if you're doing this in a spreadsheet, when you're changing the aspect ratio of the wing, it changes the lift curve. Effectively here, as you're changing the aspect ratio of this aero body, the code implicitly adjusts the lift curve slope depending on what you put in. Same for the tail, and things like thickness affect the way the affect drag, and to some extent the lift curve slope as well. Anyway, the point of this exercise really is just to quickly throw something together so we can see that we're going to get some aerodynamic forces. Okay, let's put it in the tunnel. So remember, when we're moving these things, we need to move the top level rather than anything else. Our wind tunnel is over there. Let's go back to ISO mode, out of ISO mode, and drag that across, drag the one, put it over there. Go for the top view. So if you ever lose something, select it, mouse in the scene view, click F, and then it will find it again. So square into ISO mode. There's quite a lot of jumping in and out of modes. You just kind of have to get used to using the shortcuts to visually do things. And if we look at it on the Z axis, let's put it in the middle of the tunnel. Okay, that looks alright. So our plane is in the tunnel. I'm going to do F again to zoom into it. And I come out of ISO mode. Okay, so it's in the tunnel, but bear in mind if we press play now, since we had gravity on, it would just fall straight down, so we don't want that. And what we're going to do is do a quick fix by clicking this is kinematic tick box. And what this does, without going into details, it kind of treats it as an object that can't move. So wherever we put it, it will stay there, and the physics doesn't transfer to moving this in the world. So it's a shortcut for just doing a very simple mount for a wind tunnel. The other thing we'd like to be able to do is orientate it in the tunnel. So this is the transform, so we've got our rotations here. So this X is the red axis. So if I change this, I can pitch the model up and down to change the angle of attack. And also I can change Y as well to spin it around on the Y axis. That's good. We need some wind. So if we go to our fan fluid effector, so this, as I clicked on that, you can probably see this green capsule collider thing. So that volume there is the volume affected by the wind by the fan, but actually the fast moving air is just in the disc plane of the fan, so we're going to get some air blowing through this way. And the thing you have to change on here is wind speed at fan face, and let's just put that in at 1 meter per second to start off with. This interface may change when you see it. If anything, it should become simpler, but that's how I'm changing it right now. Okay, I think we've got it all set up, but actually what we're going to do is run this so we can see it in the scene view. So let's just disable the game view for now. So not play focus, play unfocused. Remember what that does, it just means that we can stay in this scene to see what's going on. Okay, let's play it, see what happens. Okay, so we've got our fan going round, and we can see a little bit of wind coming off it. It's only going really slowly, but if you look really carefully, it's a good sign. We've got a little green arrow showing we've got some lift coming off our wing. So let's try increasing the fan speed. And there, as we increase the fan speed, you can see the lift goes up on the wing and the tail, and our drag goes up, which is just what we want to see. And notice there that the drag is in the direction opposite to the wind. The lift has actually got an induced drag component in it, so it's not quite perpendicular to the wind, but this includes basically the effect of induced drag on lift. What else can we do? Let's now vary the angle of attack. So if we decrease the angle of attack to 0, lift goes to 0. Increase angle of attack, lift goes up, lift goes up, lift goes up until a certain angle, and then bang, it stalls. So that's the stall kicking in there. So the aero model there recognises above a certain angle of attack the wing's going to stall, and it drops off. But notice that drag is carrying on increasing enormously. So that's the classic stall behaviour. You lose your lift, but the drag goes up. And let's decrease. And if you're at a negative angle of attack, same thing happens. You get drag, but this time you get negative lift going down. And the last thing to look at is if we vary the side slip. So if we go sideways that way, if you look there, you can see our little fin. Turn the gizmos off. So we're flying sideways. There's a lift force on the fin that way, so what that's going to do is push the fin that way, and it's going to point the aircraft back into the wind. So that means our fin is acting as we would want it to. It's behaving as a stabilizing device, and equally as we go the other way, you can see there the fin is pushing the aircraft back into the wind. Put our gizmos on, and let's just highlight these again. So I'm doing shift of all those. So there we go. So what we've done is taken our blocky plane, which had graphics on it, and it had some inertial properties, so it fell with gravity and you could apply forces to it. But now what we can do is we can apply aerodynamic forces. So we've set the shape of those objects with our AeroObjects, and we have given them lift and drag models and visualized them. And then by setting this in a wind tunnel, so we've got a zone here in our virtual space which is having wind on it, we can see that the aerodynamic forces are about what we would expect for a plane like this. So this means that our aerodynamic object is talking to the rigid body. What else do we need? As a little bit of a housekeeping component, we also need something to be able to detect wind in the environment. And to do that, we're going to use a collider object, but for slightly different purposes. So what we're going to do is add in a sphere collider, and that comes up pretty quick if you type in SPH. And this is going to be used as a kind of a sensor, so that we know that when that collider is inside, for example, the wind tunnel, we know that it's going to pick up the wind tunnel speed. And it doesn't need to be very big, so I'm going to just make it small so visually it doesn't get in the way. And in fact, if I turn gizmos on, we can see a better idea of what we're doing. So we plonked in. Let's start again. Okay, so we've got our wing selected. Look in the inspector, we're going to do add component, and what we want to do is add an aero object. So typing in aero group, aero object is what we need. And it's going to have drag and it's going to have lift. And we can ignore the other things for now. But the rigid body, it needs to know where it's going to apply the forces. So gravitational forces and things were applied to the rigid body. We now want to apply our aerodynamic forces to that rigid body. So we need to give a link to that. And that rigid body was at the top of the hierarchy. So if we drag in whatever you called your plane to there we go, it's found the rigid body attached to blocky plane. Okay, that's good. In terms of the sizing, we can't actually see anything, but what we do, if you turn on the gizmos, that button at the top there, you can see that this kind of net sphere has been put in, and the default aero body is just a sphere, so it's just a blobby body, and what we need to do is change the shape of that to fit the geometry of the wing. And to do this, I'm going to be using the kind of hotkeys on the keyboard. It's just much quicker to do it with those, and the ones you need to know about are, if you hit R, that rescales. You can see these handles now become cubes. And what I can do is squash it and stretch it and shrink it to turn it more into something that's a wing. But to make this easier for myself, I'm going to do a top-down view, and I'm also going to, if I click that middle one there, it's going to go isometric on me, so everything's a complete plan view. Okay, so I guess pretty good on the span, but I also need to move it, and that's W. That goes back to your familiar arrow ones you've been using before. I'll stick that in the middle, click R again, I can shrink it, and that'll do. That's a wing. Let's just check the side view. Oh, that's pretty thick for a wing, so actually let's make it thinner. It really doesn't particularly matter at this stage how we do this. This is really just to get an idea of how it works. So we've got the wing on there, we've made it quite thin. It's okay. Good. What else do we need? Since we're going to test this in a wind tunnel, we need a kind of sensor on this that detects if there's any wind objects in the scene. And to do that, we use another collider, and that collider is not used to detect whether you hit a solid object. That collider is used to detect whether you're in another collider which contains wind. Details aren't important, but what we need for that is a sphere collider. You can see this big green thing's appeared here, and basically when this any wind that this detects will be then applied to this object. What I'm going to do is make it just a bit smaller so visually it doesn't get in the way. And there we can see it in the middle. So this is our detector for wind. And what else? Some visualization. Well, always the hard thing with aerodynamics, you can't see things, but this is virtual reality or virtual worlds. We can see things, and what we're going to do is add a lift arrow, and what this will do is the aerodynamics are worked out for this object, and then this lift arrow, the length of it will change shape depending on the amount of lift. It's 20 centimeters in diameter, which is a bit big. Let's make it 5 centimeters, leave the sensitivity is, and it's going to be green. Okay, happy with that. That's pretty good. Let's make the other things. Okay, so because we're lazy, we're just going to duplicate that, and let's call that tail plane. And then once we're back in here, tail plane, select W for move. We can slide it back to the tail plane. R for rescale. Thin it out a bit more. Okay, and we've got ourselves a tail. Almost no effort. And let's do the same thing again for the fin. So the fin is swiveled round, and it's going to be swiveled around on the Z axis by 90 degrees, and it's going to be a bit more stubby than the tail plane. Slide it back up. There we go, we've got ourselves a fin. So the aerodynamics are based roughly on that shape, so that ellipsoid shape gives you the effective aspect ratio of that surface. So the thing that does matter, the wing has a higher aspect ratio than the tail, and that determines the lift curve slope of these surfaces. So if you're ever working these things in a spreadsheet and you're trying to work out the lift curve slope correction, use aspect ratio. The code does the same thing. It takes the shape you've drawn and then bases the aspect ratio on that. Okay, lastly we want something for the fuselage. It's going to be slightly different, but let's just do another copy and paste job. Let's call that fuselage and rescale it. So it's going to be longer, it's going to be thinner that way but fatter that way, and I'm going to look at it sideways on. Rescale, W for moving it, sticking it in the middle, R for rescale. Look at it end on to see if it's about the right size, or it's a bit skinny that way. Okay, that'll do. We've roughly fitted a body. So that's kind of ellipsoid body shape, and it's going to have drag, but it's not going to have lift. It's a non-lifting body. So what the code will do is it'll take that ellipsoid, and it'll be a sort of variation on drag on a sphere, but changing depending on which way the wind is coming from and the aspect ratio of this ellipsoid. Hasn't got lift this time, so let's get rid of the lift arrow and let's add in a drag arrow so we can see what's going on. Make it a bit smaller so it doesn't overwhelm the size, and because drag is so much less than lift, I'm going to increase that up to around 40 just so it just visually makes it much bigger so we can see what's going on, and the drag is going to be red. Okay, and if we select all of these, we can see the job we've done on the aerodynamics. So as an aerodynamicist, you see a plane actually made up of separate bodies with different jobs. So wing producing lift, the tail is all about stability, vertical tail, directional stability, and fuselage is for putting things in, just has drag and no lift. But this kind of component build-up approach to aerodynamics is a kind of fast, low-order method of getting about the right answer, which is kind of a level up from what you might get in a spreadsheet. Okay, so we've got our plane. We need some wind, so where are we going to get some wind from? As it happens, we have a wind tunnel in the scene. Let's go back into ISO mode. And this wind tunnel is essentially a zone where we apply a numerical wind to things. There's some visualization on it just to help appreciate what's going on, but essentially there's if we select the fan fluid effector, you can see that big green collider, capsule collider around it, and within that there's a function that says if you're downstream or if you're in the line of this fan, there'll be a wind speed going that way, and it slowly peters out the further you go away, and there's a bit of entrainment as well. But essentially this is kind of a numerical wind tunnel, and what that will do is those little colliders, that sphere colliders we put on those objects, will sense where they are, and it will sense what the local wind speed is. So let's drag our plane into the wind tunnel. So W for moving, drag it over there, lifted it up by mistake, slide it sideways, look vertically, F, oops, to zoom in. Wasn't selecting the plane, select the plane, F for focus, and little square turns it into ISO mode, Lots of things going on here. It takes a while to get used to all the shortcut keys in Unity. You get there eventually. That's our X view. We've just put ourselves in the middle of the wind tunnel. Okay, that's looking okay. Back to ISO mode. Going to turn gizmos off so we don't have to see the mesh. And if you remember when we ran it before, because there's gravity and everything else, this plane will just sink and get blown backwards. So what we're going to do with the plane selected, rigid body, what we're going to do is click this is kinematic, and what that'll do means that essentially it treats it as an object that can move, but basically it's fixed in space. It doesn't really matter exactly what it does. It's just an easy way of fixing it, and we can still apply forces to it. Everything else remains the same, and in the wind tunnel we can change the speed of the fan, but more importantly we can change the angle of attack. So imagine this is mounted in the tunnel, so if we rotate around the x-axis, we can change the angle of attack like that, and we can change the angle of side slip by moving it around like that. And we can do just a quick check to make sure that the plane behaves as we hoped. Okay, we're going to stay in scene view, so let's go onto there, make sure that's on play on focus so it doesn't jump around when we press play. So we're going to stay in the scene view. Okay, and what else do we need to do? Fan fluid effector. The wind speed is set here, so let's set it at a slow speed to start off with. So this is the only thing you need to vary on this. And let's hit play, see what happens. Okay, so we've got a little bit of wind coming from our fan, not very much, and actually if we look really closely you can see a little green arrow on the wing, so we're getting a little bit of lift, which is good. So let's increase the fan speed, and there we go, we're getting more lift, and then you can see there's lift on the tail. It's a smaller amount because obviously the tail is smaller. So that's looking good. So that's positive angle of attack, we're getting lift. Go back to selecting the plane again. If we change the angle of attack, so increase the angle of attack, lift gets bigger, and then it stops and it starts coming down. So that's the stall behaviour, which is correct. So as the angle of attack is going right up, we're getting a little bit of lift, but not so much. Yeah, the wing and the tail are stalling at different times. And then of course if we go negative angle of attack, we're getting negative lift, so that's good. Side slip, if we go sideways, it's like get slightly less lift because the wing is going sideways, but then if you actually look at the fin, we zoom into the fin there, you can see that as we move the fin, there's a side force on the fin, so that would mean the aircraft is stable because it's pulling the fin back round, to making it yeah, point back into the wind as you want. So fantastic. What we've done there is put our gizmos back on. There's our plane, our aerodynamic objects. We've taken our graphics and we have added some aerodynamic components now, so that determine or sense what the local wind is relative to their geometry, and from that we'll generate aerodynamic forces. So we've got the basis now of a flying aircraft.